Well, hey there, everybody. It's your boy, Mr. Perry. And we're going to be continuing the journey here with Unit 1, Lesson 3, talking about variables and data types. Again, most of this lesson is going to be review from AP CSP, but as always, pay attention to what's review and what is new. So, speaking of review, let's just pause and do a little bit of review. Hopefully, you've learned a little bit about variables already. Even if you didn't have AP Computer Science Principles, you probably recognize the word variable from maybe an algebra class. So just pause really quick here and think about what do you know about variables or what do you remember about variables. And if you've taken Computer Science Principles, why or how are variables important to programming? And can you remember the rules about naming variables? So just take a second and think about that and then continue with the video. All right, I'm going to assume you took the time to do your review. Let's go ahead and jump into what we need to know about variables in Java. So first off, a variable by definition is a name that is associated with a memory location in the computer. You have to remember our computers will store things for us. It'll store things like your name or your score in a game or your age. All of that information, all of that data needs to get stored in the computer, which means it needs to be assigned to transistors, bits that are in that computer. So when you name something, when you give it when you declare a variable and you give that variable a name, that name is essentially a pointer. It is associated with a specific area in memory, and we're going to do a deeper dive into this later on. So remember that a variable stores a value, but that value can change. So an example, it says string player name equals Hulk. So in this case, player name is your variable, and it is storing the string Hulk. But of course, if the player name changed, then it would become something different. So variables, can change what it is they are storing. So there you go. Player name is your variable. Okay, so in Java, you need to do two things. Well, really, in programming in general, you need to do two things. First thing you need to do is declare the variable. So if you type the data type and then the name of the variable, so down here, string player name, and then you see the semicolon is right there, or double average score, and then here's your semicolon, or down here, album 1. So player name is the variable, average score is the variable name, and then album 1 is the variable. But the first thing you need to do is type the data type. So that's something that's different in Java. So the data type for player name is string, and the data type for average score is going to be double. And then the data type for album 1 is going to be album. That means it's going to come from the album class. So what happens when you declare a variable? This reserves memory space associated with the variable's name. So as soon as you type in string player name, it reserves an area in memory, and player name is now basically connected with that, or it's associated with that area in memory. And when you say double average score, again, a certain amount of bits are dedicated in Java or in the computer's memory to store whatever double this is going to end up being, and the name average score is a pointer. It is associated with that area in memory. So step 1 is to declare the variable. Step 2, you must include the data type and then the variable name when declaring a variable. That's one thing that's always going to be true. Those two things need to happen. Now the next step, of course, is initializing the variable, which is where we assign a value to the variable name using the equal sign. And this stores the value in that memory location. So before we said string player name, that declared the variable. If I now say player name equals Hulk, so I've now used the equal sign to initialize the variable, which means this string literal Hulk is now being stored in that same location in memory that is associated with player name. And before we just said double average score. So that just kind of opened up a little area in memory. Now what we're saying is okay, average score equals 89.5. So now this value of 89.5 is being stored in that memory location. And similarly, when we said album 1, this declared a variable called album1. Now we're using the equal sign and it says new album, The Beatles. So what we're doing here is we're creating an object of the album class, and we are associating that with this variable name album1. So that area of Java memory that we associated with album1 now has the album The Beatles in it, and that's basically how it goes in Java. So you look at it as two separate steps. However, you can declare and initialize in a single line of code. You can do these in separate lines of code, or you can do it in a single line of code. So here it says int cardnum, and then down here it says cardnum equals 5. So up here I'm declaring the variable, and then down here I'm initializing the variable. I can also just do it like you see down here. I can just say int cardnum equals 5, and this handles both the declaring of the variable as well as the initializing of the variable. All right, so here's declaring the variable, here's initializing the variable, here is declaring and initializing the variable. All right, so data types. What do you need to know about data types? Well, there are two main types of variables. You have what are called primitive data types, and those include ints for integers, double for any decimal point that we need, and then booleans for on or off or true false type variables. Now, what's interesting about primitive data types is they require only a fixed amount of memory space, and they always begin with a lowercase letter. So they're easy to spot because they are always lowercase. You can always tell an int is a primitive and a double is a primitive and a boolean is a primitive because of the lowercase I, D, and B. But they also require just a small amount of memory space. So it's just a fixed small amount of memory that is required to store these data types. Now, it's good to know that there are also other primitive data types, such as CHAR for character, and then long and short for some of the different decimals that you can have. But these three, int, double, and boolean, these are the only three that appear on your AP CSA exam. So for the most part, they're the only three that we're going to be really dealing with in the class. Now there are also what are called reference data types. Reference data types are easy to spot because they are always capitalized. So you'll notice the S in string is capitalized. When we get to arrays and array lists later on in the class, you'll notice again that they are capitalized, and that's because they are reference data types. And then also objects of a class are also reference data types. Now reference data types act as pointers to a memory address where the information is being stored. So reference data types are a little bit different because with primitive data types, you only need a fixed amount of memory space. So for a Boolean, for instance, you literally only need a single transistor to be on or off to represent true or false, or yes or no. So it only needs a single transistor. Ints and doubles require a little bit more, but again, they don't require very many. Now, when you get to reference data types, the problem is you don't really know, and the computer doesn't really know how many bits are going to be necessary to store a string. So for instance, a string could be just a single character. It could also be an entire sentence, right? So it could be really small. It could also be really, really long. So reference data types don't get just a fixed amount of data. They get an area of data. They get kind of like a whole region of bits that are kind of assigned to it, and that's just to make sure that it can accommodate for however large or however small it ends up being. So more on this in the future. Just basically know that there are primitive data types and there are reference data types, and they're pretty easy to spot the difference between the two because primitive data types are all lowercase, whereas reference data types get capitalized. Okay, let's wrap this up. There's also the keyword final, which can give you what's called a constant. So if you add the word final at the beginning of declaring a variable, then what you're doing is you're creating a variable that cannot change. In other words, you're creating a constant. So a common one is final double pi, which is going to be obviously 3.14. And unlike typical variable names, constants are typed using all caps. So anytime you see the word final at the beginning of a line of code and then you have a data type, then you would expect that the variable name is going to be in all caps, which is what you see right here. All right, let's just do a quick little practice here to see how well you absorbed our information. So read through this, what's in blue down here, and see if you can identify any variables that would be necessary to make this program run, and then also the data type. So again, just trying to identify any variables and maybe their data type. So Lucy needs to keep track of her store's inventory and how much money she has made. Go ahead and pause the video and see if you can figure out what would we need a variable for, and then what kind of what data type would that need? What data type would that be? Okay. So when you're thinking about variables, you're always thinking about, well, what could change? You know, what could either increase or decrease? What are you keeping track of here? So obviously you're keeping track of your store's inventory. So how many items do you have in your store? So that would probably be an int, right? Because, you know, maybe you have 10 items, maybe you have 100 items. As you sell things, that's going to go down, so it's going to be variable. And then obviously, how much money have you made? Well, that's going to need to be a double, because when you're dealing with money, you're dealing with, you know, you might have some decimals, right? There could be whole dollars, but there could also be change. So, you know, how much money that you have made would be a double. There you go. Let's try this one. Alex wants to write a program to keep track of his family members, their age, weight, and height. So just take a second here and think about how many variables would this program need and what would their data types be. Okay, I'm assuming that you paused the video. So family members, you'd want to keep track of their names. So that would be string. You would need a bunch of strings to hold the family members' names. Age would probably be an integer. And then weight and height, depending on how you measured it, would be either an integer or maybe a double. You know, again, just kind of depends on how you're measuring and how you're recording it. But if you are going to be using anything with decimals, then obviously you would want doubles. If you're sticking with whole numbers, then you would go with ints. All right, last one here. Michelle wants to create a game that will allow multiple players to play several rounds of the game, check their average scores, and then see who has the highest average score. So again, pause the video here, think through this scenario, and think about, you know, again, what would our variables be, and then what would their data types be. I'm assuming that you went ahead and did that. So it really just kind of depends on how you approached designing this game, but if you're going to have multiple players, then you might want to store their names, or at the very least it's going to be player 1, player 2, player 3, player 4, right? So you would need strings to store that. Now you would probably need integers to store the score that they play on each round. But then when you create the average, you're going to need a double because, of course, if you play like 3 rounds of a game and then you average your score, there's always a potential for a decimal point. So you would want a double for your average score, but integer for the score itself. And then, of course, seeing who has the highest score you would again use a string for that, because whoever's got the highest score, you're going to want to obviously hold on to that person's name. So once again, that would be that would be a string. Okay, let's go ahead and wrap this up. We've got some things that we need to keep in mind when we are naming variables. The name of the variable should describe the data that it holds. That's very important. Variable names should always be at least somewhat descriptive. They start with a lowercase letter and then use camel case if it's more than one word. Variables can not begin with a number, and you don't include spaces when you are doing a variable name. If it's more than one word, again, you just use camel case. You can, by the way, use an underscore instead of camel case. You will see people do this instead of player score. So if you did int player score using camel case, it would look like this. But you'll also see people do int and then player underscore score using the underscore sign as taking the place of the space bar. But your AP exam will use camel case. Most of my examples are going to use camel case, so that's just what I tend to fall back on. All right, and then some common issues. Variable names not being descriptive enough. Some people will just use really bland and generic variable names, and sometimes they just aren't descriptive enough. So that's one thing to keep in mind, is you always want them to be descriptive and somewhat specific. However, you don't want to use overly long names. Variable names should be relatively compact, maybe 2, maybe 3 words, at most. Avoid trying to be funny. Some people will look at, oh, I get to come up with a variable name. I'm just going to come up with something goofy and silly, which, can be fun. Obviously, it can get a laugh, but it's not good practice. And then also single letter variable names, like X, for instance, are also not good. It makes your code really hard to understand. So some people will just say int X equals, 5, and then int Y equals whatever. And you'll actually see that on your AP exam. Sometimes they will give you multiple choice questions where the variable names are just like a single letter of the alphabet. And just know that, obviously that's not how you would normally name your variables. All right, so lesson review. A variable is a name for a memory location where you can store a value that can change or vary. Int, double, and boolean are primitive data types. Their specific values are stored using a fixed number of bits. But strings, arrays, and objects of a class are all reference data types, and their values are stored in areas of computer memory as opposed to just fixed bits. The keyword final creates a constant value in a variable. And then, of course, anytime you're writing a program, make sure that you follow make sure you follow the rules of naming variables, such as keeping them short and descriptive, and using camel case if it's more than one word. All right, guys, as always, at the end of the video, it's time to leave a question, a comment, or an observation on Classroom. So head on over there and be sure to post something for us to use as a start for our discussion tomorrow. Thanks so much, and I will see you in class.